Here's problem 3046. Two long parallel wires lie in the xz plane. One wire passes through the point -2, 0, 0, and the other through the point +2, 0, 0. The wires carry equal currents in the positive z direction. So let's imagine what's going on here. Here's our x direction, here's our y direction, and z is coming out towards you. Here's a -1, -2, here's 1, 2, 3, -3, and we have a current here coming out of the page towards you. Let's call that I1. And we have another current at x = 2 also coming out of the page towards you. We'll call that I2. And so we want to evaluate what the magnetic field looks like at various points along the x-axis. Now, in general, we're going to have magnetic fields going circularly around these wires, and where the x-axis is concerned, those magnetic fields are going to be perpendicular to the axis, so they're either going to be positive y or negative y at any particular point. For instance, if we consider x = -3, if we look at I1, there's going to be a magnetic field going around like this, and it's going to be a large magnetic field. Let's call it B1 because we're close to the wire. You know, B in general is mu0 I over 2 pi r. So if you're close to the wire, the magnetic field is going to be larger. And we're kind of far away from I1. And if we point in that direction, actually I2 is also going to contribute to a magnetic field in the negative y direction. So they're both going to be contributing to the same direction. The magnetic field will be in the negative y direction. So statement number 1 is true. Let's look at point -1. At -1, we're going to have a B1 going up like this, relatively strong because we're close to I1 still. And then for I2, we're going to be coming around like this, and we're going to be going in the negative y direction like this, but not as strong as B1 because we're further away from I2 and the two currents are equal. So since we're further away, B1 is going to win, and this will be in the positive y direction. So the statement that the magnetic field is in the positive y direction there is also true. Look at 3. Look at point x = 1. In terms of B1, we're going to have a magnetic field going circularly around here. By the right-hand rule, it's going counterclockwise. So B1 is going to be going up like this. Rather weak because we're kind of far away from current I1, but we're closer to I2, and we're going to be going counterclockwise for that. And that's going to be much larger because we're closer to it. So we're going to end up with a net magnetic field that's in the negative y direction. So the fact that it says magnetic field's in the positive y direction is false. Let's look at x = 3. If we look at I1, we're going to have a magnetic field going circularly around, but we're really far away from that current. And that's going to be a relatively weak magnetic field, B1. We're a lot closer to I2, and we're going counterclockwise as well on that. So that magnetic field, B2, is going to be strong in the positive y direction. So they both are going to be in the positive y direction. So saying that the magnetic field is in the negative y direction is simply false. So statements 1 and 2 are true. Statements 3 and 4 are false. The answer then is to say that 1 and 2 are correct, because that's the only one of the options that is correct.